Hi everyone, I'm Shubham Jhanwar. I'm a master teacher at Vedantu. We are discussing JEE Advanced 2018 Paper 2 Mathematics. And the question for this video is this. Let there be a function f whose domain is 0 open to pi open and the codomain is all real values. Be a twice differentiable function such that limit t tending to x, f of x sin t minus f of t sin x divided by t minus x equal to sin square x for all x in this interval 0 open to pi open. If f of pi by 6 is equal to minus pi by 12, then which of the following statement is or statements are true? So it is a multiple correct type question. There are 4 options and we have to find which of these are true or correct. Now clearly first thing that we would be bouncing at or we will be attacking is to find the function f of x. And it's also again quite obvious that here as t tends to x, numerator tends to 0, so does denominator. So we'd be using L'Hopital. So using L'Hopital, we get limit t tending to x. Mind it, we are differentiating numerator and denominator with respect to t. So here it becomes f of x cos t minus f prime t sin x divided by 1 is equal to sin square x for every x in this interval 0 open to pi open. Now, basically it becomes as t tends to x, you have f of x cos x minus f prime x sin x is equal to sin square x. And it is a linear differential equation. And this can be solved using linear differential equation concept, using integration factor and all. However, there is a better way of doing this. You may just cross multiply sin square x. Anyway, sin square x is never 0 because x is in this interval 0 open to pi open. So here you may take it this way, f prime x sin x minus f of x cos x by sin square x is essentially minus 1. And if you see this carefully, this essentially becomes d by dx of f of x by sin x equal to minus 1. So using quotient rule, you can easily check that d by dx of fx by sin x is essentially f prime x sin x minus fx cos x divided by sin square x. Now if you integrate both sides with respect to x, I would get f of x by sin x equal to minus x plus arbitrary constant c. Now here we know f of pi by 6 is equal to minus pi by 12. So when you put x to be pi by 6, f of pi by 6 you'll put to be minus pi by 12 divided by sin of pi by 6 is half. So basically it becomes minus pi by 6 on left hand side. And on right hand side, as we have put x to be pi by 6, it becomes minus pi by 6 plus c. So that clearly means c is supposed to be 0, and that also means f of x essentially becomes minus x sin x. Now few of the options, especially option A and D, are very quick, easy to solve. F of pi by 4. So as you put x to be pi by 4, you get f of pi by 4 to be minus pi by 4 root 2. However, here it is given pi by 4 root 2. So this is not true, hence not part of my answer. What about D? Here f of x is minus x sin x, and we are interested in f double prime pi by 2 plus f of pi by 2. So basically we would be finding f double prime x. So if f of x is minus x sin x, what about f double prime x? So f of x is minus x sin x. So that essentially means f prime x essentially becomes minus sin x minus x cos x. And what about f double prime x? F double prime x would become minus cos x minus cos x, so minus 2 cos x plus x sin x. So what about f of x plus f of double prime x? So essentially this will become, if you see carefully, minus 2 cos x. And as you put x to be pi by 2, left hand side becomes f of pi by 2 plus f double prime pi by 2, and right hand side, since cos pi by 2 is 0, it becomes 0. So that essentially means D is correct. Now let's go for the C part. There exists alpha belonging to 0 open to pi open such that f prime alpha equal to 0. Now it is very tempting to use Rolle's theorem. However, here f of x has domain 0 open to pi open and not 0 closed to pi closed. So yeah, what we may do, and there is a subtlety here that we can take some other function capital F of x to be minus x sine x, because minus x sine x is defined for all real values of x. So let me say there is a function capital F of x being minus x sine x for every x belong to real. And on it, let me apply Rolle's theorem, so to speak. Yeah. And we can clearly see capital F of x and small f of x would coincide, would be the same when x is between 0 open to pi open, because small f of x is defined only for 0 open to pi open. Nonetheless, you may apply Rolle's theorem in the interval 0 closed to pi closed. Capital F of 0 is 0, capital F of pi is also 0 because sine pi is 0, and it is continuous differentiable everywhere. So you may say there exists, some alpha in this interval 0 open to pi open, for which, capital F prime x equal to 0, or you may say capital F prime alpha equal to 0, using Rolle's theorem. And since capital F of x and small f of x coincide in this interval 0 open to pi open, so you may say there will be the same alpha for which, small f prime alpha would also be 0. So a bit of subtlety here. Just to emphasize, I have taken it capital F of x, otherwise you would have just gone with this small f of x also. So that means C is correct too. Now let's check B. F of x less than x to the power 4 by 6 minus x square for all x in this interval 0 open to pi open. So here, essentially I have been asked to compare f of x with x to the power 4 by 6 minus x square. We want to explore whether f of x is less than x to the power 4 by 6 minus x square in this interval 0 open to pi open. Now what is f of x? F of x is essentially minus x sine x. So we want to explore whether this is less than x to the power 4 by 6 minus x square or not. Essentially we want to compare sine x with x cubed by 6, or I should say x minus x cubed by 6. If you divide both sides by minus x, because since x is supposed to be between 0 open to pi open, x is not 0, so you may divide by minus x, which definitely would be negative, and the sign would reverse, and you get like this. You may even write this as 3 factorial. So we want to compare sine x with this, essentially, for x being between 0 to, you may say, pi open. Now there may be different ways of commenting upon whether this is true or not. So let me consider a function g of x as sine of x minus x plus x cube by 3 factorial. Now here I can clearly see g of 0 is 0. What about g prime x? It is essentially cos of x minus 1 plus x square by 2. Now cos of x minus 1 would be negative, or rather I should say non-positive for all x. However, x square by 2 will be non-negative. So here we can't say for sure whether g prime x would be always positive or not, or for that matter always non-positive or not, or always non-negative or not. We can't comment for sure as such. So let's go for one more differentiation. However, before doing that, let's note that g prime 0 is 0 again. Now what about g double prime 0? Oh, my bad, g double prime x. It's minus sine x plus x. And this is a very popular expression, and we know this is positive for every x greater than 0, what to speak just about x being between 0 open to pi open. So that means g prime x is increasing in x being between 0 open to pi open. That means g prime x is greater than g prime 0 for every x between 0 open to pi open. G prime 0 is 0. So that means g prime x is greater than 0 for every x in this interval 0 open to pi open. That essentially means g of x is increasing, which in turn mean g of x is greater than g of 0 for every x between 0 open to pi open. That essentially means since g of 0 is 0, g of x is greater than 0 for every x in this interval 0 open to pi open. Now what is g of x? G of x is essentially sine of x minus x plus x cubed by 3 factorial. So for this to be greater than 0 for every x in this interval 0 open to pi open, that means sin x is greater than x minus x cubed by 3 factorial for every x in this interval 0 open to pi open, which in turn would mean f of x less than x to the power 4 by 6 minus x square for every x in this interval 0 open to pi open. So that means this holds indeed in this interval 0 open to pi open. So that essentially means B is correct too. Now let's see an alternate to prove that B is true. We may say the method that we'll be using now is related to the method which we have just now used. So here what you may say is, we may start with sin x less than x for every x greater than 0, and also for x belonging to 0 open to pi open, because it is a subset of x greater than 0. Now starting with this, we can draw our conclusion. That means we can reach option B. So here we can say minus sin x will be greater than minus x for every x in this interval 0 open to pi open, and let me not write this again and again, this is understood. So let me consider this, that since this would hold, minus sin t integral with respect to t from 0 to x would be greater than integral minus t dt from 0 to x. So that essentially means cos x minus 1 is greater than minus x square by 2. That means cos x is greater than 1 minus x square by 2. Let me write it again for every x in this interval 0 open to pi open. Now again, what will I consider? Because of this, I may say integral 0 to x cos of t dt is greater than integral 1 minus x square, or my bad, t square by 2. Integrated from 0 to x, this would hold true. So that essentially means sin x is greater than x minus x cube by 6 for every x in this interval 0 open to pi open. Now since x is in this interval 0 open to pi open, it is positive, minus x is negative. So if I multiply both sides by minus x, the sign would reverse. That means minus x sin x, which essentially is f of x only, would be less than x to the power 4 by 6 minus x square for every x in this interval 0 open to pi open. So hence we have again proved that f of x is less than x to the power 4 by 6 minus x square for every x in this interval 0 open to pi open. Thanks for listening. Stay tuned for the next question.